Let's talk about the permutation and combination formulas. What's actually happening here? So say that I have an ice cream shop and we have 10 flavors. And today's special, you get to choose 3 different flavors and you get to have it in either a permutation cone or a combination bowl. How many possible options are there for each? First, what's the difference between these two? Well, order matters for a permutation cone because vanilla chocolate strawberry and chocolate strawberry vanilla are going to be different experiences. Versus combination bowl, order doesn't really matter. Whether you tell me vanilla chocolate strawberry or chocolate strawberry vanilla, I'm going to give you the same thing. Let's start with the permutation cone. How many possible options are there for the first scoop? 10, because there are 10 flavors. And remember, you need to pick 3 different flavors, so that means there are 9 options for the second scoop, and then 8 options for the third scoop. But what do we do with these numbers? The fundamental counting principle says that we multiply these numbers, and we can see this using a tree diagram. We see that there are 10 options for the first one, 9 options, and then 8 options, so altogether we would have 720 different options. Now one might say this kind of looks like a factorial, but part of it is chopped off, like this. So it's the start of 10 factorial, but how do we get rid of this part? Well, divide by 7 factorial. If we divide by 7 factorial, we get the first 3 terms, 10 times 9 times 8. Now we need to figure out, how does 7 relate to 10 and 3? Well, 7 is 10 minus 3. So that's an example of how to make sense of the permutation formula. All this is doing is asking you, how many terms of a factorial do you want? Now, how do we make sense of the combination formula? Well, the permutation and combination formulas look very similar. The only difference is that for combination, you're dividing by r factorial. So how does this come into play? Now, the difference between a permutation cone and a combination bowl is that order doesn't matter in combinations. So if you give me the 3 flavors, you can say vanilla chocolate strawberry or strawberry chocolate vanilla, and I'm going to give you the same thing. For every 3 flavors, we can list them in 6 or 3 factorial different ways. And it's 3 factorial because we have 3 options for the first, 2 options for the second, 1 option for the last. But remember, in combinations, order doesn't matter, so all of this counts as 1. That's why over here, with the 720 different options, we divide by 3 factorial because every group of 6 counts as 1. So overall, for permutations, all this formula is doing is just listing part of a factorial. And for combinations, it's the permutation formula divided by r factorial. And we are dividing by r factorial because groups of r factorial in the permutation list counts as 1 since order doesn't matter.